So today the title of our notes is 3.4 and 4.7, Triangles Intro, and we're going to discuss medians and altitudes and something called a triangle angle sum theorem. But first, before we begin, I want us to complete this do now. So look at the diagram, pause the video, and finish these two sentences. So after you've practiced completing this vocabulary, we can see that line AB is perpendicular to line segment XY. And we also see, because of these congruent symbols, that line AB is the bisector of line segment XY. So perpendicular lines are when two lines intersect, they create a right angle. So in this case, we could say line AB is perpendicular to line segment XY. So we can always see the right angle, and this symbol means is perpendicular to. Okay, so we're going to use some symbols. Perpendicular is a long word to write out, so we're going to use the symbol for it, this upside down capital T, which actually looks similar to what we have in the diagram. Okay, so now we're going to blend together that do now. So something else that we have a perpendicular bisector. So since AB is perpendicular to line segment XY, but line AB also bisects the line segment XY, we can call line AB is a perpendicular bisector. So it's a line that divides a segment into two congruent parts, which is the bisector, and then the line that also creates a 90-degree angle with the line segment, which is the perpendicular piece. So we have a perpendicular bisector. Okay, so now we're diving into what a triangle is. So we all know what a triangle looks like, but how can we describe what it is? So how many points do we have in a triangle? And everyone's thinking about this and saying it out loud. How many line segments are in a triangle? Okay. And thinking back to that first unit, we know that it's an enclosed figure with three line segments joining three non-collinear points. So when we drew planes in the first unit, we actually drew a triangle, right? Three non-collinear points created a plane. So those three non-collinear points, when we connect those lines, we have a triangle. Okay, so 3.4, triangles. I want everyone to draw this triangle, and we can name this triangle with a triangle symbol, and actually name the points. Okay, and it doesn't have to be in alphabetical order. So we could say triangle BCA. We could say triangle CBA. We can say triangle CAB. But as long as we're naming the points, okay? And so parts of a triangle, we have vertex. We have vertexes or vertices. So we have the points. Okay. So A is a vertex, point B is a vertex, and point C is a vertex. And the sides, what do you suppose the sides are? The sides are the line segments. So we can say line segment AB or BA, line segment BC or CB, and line segment AC or CA. And then we also have angles. So if there's nothing else happening in this diagram, we can actually just say angle A, angle B, and angle C, or if there are other things happening to the diagram, we can actually name it like we named angles in the last unit. So triangle B, angle BAC, and then we can say angle ABC, and we can say angle BCA. Okay, so notice how we have the vertex in the middle when we're naming that angle. Okay, so triangles can be classified by its angles and its sides. So let's think about how we can name triangles. So I want everyone to use this as an opportunity to like pause and think and write down the different types of triangles that you know. So pause, think, what are the types of triangles that we could identify or classify? And after you've paused and thought about that, please continue the video. So here are the ways that we can classify triangles by their angles. We have right triangles. So if I drew a triangle with one right angle, that is a right triangle. So a triangle with one right angle is a right triangle. We're going to talk more about right triangles throughout later on in the unit, but for now, that's a good definition. An obtuse triangle, maybe we didn't think about, but an obtuse triangle is a triangle that has one obtuse angle. Okay. Then we have an acute triangle. This is a little different. An acute triangle. Oops, that kind of looks right. An acute triangle has three. A triangle that's a triangle symbol, that has three acute angles. And then we have something called an equiangular triangle. So think about equal. So equi means all of the angles are congruent. And how many degrees are in a triangle? Some of us may know this as prior knowledge. So how many degrees are in a triangle? We're going to talk about this later in the notes, but there are 180 degrees total in a triangle. So for an equiangular triangle, all the angles are congruent, and all the angles would be what measure? 180 divided by 3, you get 60 degrees. Okay, so now we have classification by sides. So a scalene triangle. A triangle with no sides congruent. So all the side lengths are different lengths. Equilateral triangle, we know that all the sides are congruent. And then isosceles. So think about eye, right? Think about how many eyes we have. We have 2. So isosceles triangle, we have a triangle with 2 congruent sides. But it gets a little trickier than this. So it's a triangle with at least 2 congruent sides. So we're going to have a whole lesson on isosceles triangles and more about these specific triangles later on in the unit, but this is just to kind of get the vocabulary going. But we have equilateral triangles have 3 congruent sides, But an isosceles triangle is a triangle with at least two congruent sides. So an isosceles triangle could also look like that, which is an equilateral triangle. So that one gets a little bit tricky. Okay, so looking at this diagram, I want us to pause and I want us to name the following triangles. I want you to name a right triangle, an isosceles triangle, and a scalene triangle. Okay. So before you begin, ask yourself, how many triangles are there in the picture? I count many, right? I got 1, 2, 3, 4, 5, that big one, and then 6, that other big one. So we have 6 triangles in here. Actually, we got more than that. I missed one. 7, 8. I think we have 8 triangles. So let's find within those 8 triangles a right triangle. So here's one here, triangle ACB. Okay. And notice how all of these triangles could be congruent, because we know that if one of those angles is right, then all of the others are right from that first unit that we had. An isosceles triangle, so I notice here we have A, B, D is a triangle, or notice the 2 tick marks, we got this one down there as well. Okay, and then a scalene triangle, so none of the sides are congruent. So a way for us to look at this, I would say this triangle would be scalene, right? Because we got 1 tick mark, 2 tick marks, and this long line doesn't have a tick mark. So I guess we could do that one or the one that mirrors it. Okay, so now we're going to talk about different properties of a triangle. So we have a median. And a median is a segment from a vertex of a triangle to the midpoint of the opposite side. So here is the vertex. Okay, and notice how AB is horizontal. AB has a midpoint. I'm going to call that midpoint M. So the median is that green line segment that I'm drawing that connects point C of the triangle to the midpoint of the opposite side. Okay, so that's one. So we have CM is a midpoint, or is a median, excuse me. And then CA also has a midpoint. I'll call that N. So we know that BN is also a median. And then CB has a midpoint. Call that L. So from A to L, we also have a median. So there can be 3 medians in triangles because we have 3 vertex points and 3 sides. Okay, so make sure you're writing down this definition and you're comfortable with that language. And then we have something called an altitude. And an altitude is the height. So in a triangle, it is the perpendicular segment from a vertex to a line that contains the opposite side. So I'm going to start with this one. I have C here and I have AB, but I want to draw a perpendicular segment. So I could say CX is a median, okay, because it's the height. Right? And here, if I started at J and I want to draw an altitude, I want to create a perpendicular line segment. So what I have to do here is use what we have here in orange. I have to extend line segment KL, and then we could say drop an altitude here. So JX in this picture is an altitude. So sometimes the altitude will be outside of the figure. And then if we're looking at this third picture, look, we have XY and YZ. Both of these would be considered altitudes because we have that right angle there. But in total, we have 3 points and we have 3 line segments in a triangle Therefore, we will have 3 altitudes. And I think we mentioned this before in the notes, but we know that the angles in a triangle add up to 180 degrees. Okay, so I'm going to show us how we would know that. And something called the triangle angle sum theorem, which we can abbreviate to TAST, T-A-S-T. So remember back in the last unit, we had a single line, right? A straight angle is 180 degrees. Okay, so that's something else that we know is 180 degrees. So you just have to watch. So if I have this triangle with these 3 angles, I'm gonna envision I'm cutting away these angles. Okay, I'm just cutting them away. I'm ripping them away from the triangle. So if I have this one angle here, and then this other angle there, let's see how this piece can possibly fit into the middle. So notice how we have angle 1, 2, and 3. And if we add up those angles, they end up becoming a straight angle. Therefore, the measurement of angle 1 plus the measurement of angle 2 plus the measurement of angle 3 equals 180 degrees. So this is the triangle angle sum theorem. So in a triangle, the sum of the angles are always 180 degrees. So make sure you write that down, something that we'll be using. And that's it for today.